well as in society. And when that happens, we call it drought, all right? And we'll give you a particular definition of drought as we're going through it. And drought has impacts on what we call surface water resources, the water we can see around us in lakes, rivers, streams, and ponds, reservoirs, and it also affects what's happening underground. Okay, so keep in mind that we're starting to build up to this idea of a watershed, where we realize that all of our water resources, although we're going to talk about them in very specific ways, are actually all interconnected. So what happens above ground influences what happens below ground, and what's going on below ground definitely has an impact on the fresh water that we have easy access to here on the surface. This happens to be an orchard in California, I think in 2015, 2016, and we can see that all of the plants are withered, and that this particular orchard manager actually has started to dig up his trees in order to help them be able to hibernate and withstand the drought. We'll talk about the instances of what's happening in California in terms of drought today, and we'll see how their situation has changed just a little bit in the last couple of years from these extreme drought conditions like you see in these pictures today. But in this particular case, they're having to allot freshwater resources within California, and some farmers didn't get water. Okay, they were not on the list of high priorities. And as a result, agriculture really suffered in the years of the drought, 2014 through 2016 in California. And this is one example of that. We have this big almond orchard that's been entirely allowed to wither. And that has big consequences environmentally, economically, socially for the people in these regions. Okay, so I did look at those introductory worksheets that you gave me on Tuesday, and by and large, nobody wanted to stay in Ohio and have a staycation for their vacation. There was lots of different aspects of where people wanted to go. There was one person that wanted to go to Alaska, and everybody else was interested in going somewhere warm. Okay, there were 3 or 4 people that wanted to go to Hawaii. There were a couple people that were interested in going to the Caribbean. Some places in kind of tropical Southeast Asia also came up on the list. I know my next big vacation is I want to try to go to Australia and Great Barrier Reef, and nobody wanted to stay here. And that's really normal in winter semester when it's snowing outside, is we want to go somewhere that's totally different than us. I hope you realize from those worksheets and from meeting people in class on Tuesday that there are lots of people in class just like you, and that actually we have a lot of similarities, even though we might have different perspectives on things as we continue to go throughout the class. The other thing to note is this is a graph. And look, you could read it and you could get information from it. All right, set the graph up in an easy way for you to be able to do that. But we're going to look at lots of different graphs and lots of different infographics, lots of different images that are trying to impart information to us throughout the semester. And part of this class is to be able to get information out of these visual tools that we're constantly bombarded with. Some of them will be super simple, like this particular one. Other ones are going to be really complex heat maps that are showing us different things on a couple different scales. And so that's a big part of this class, is to practice reading scientific information and being able to pull information that's important to you out of it. Okay, so be aware of that, be prepared for that. The big important things in your textbook, which several of you have in class today, which is totally awesome, are the figures. And that's what we're going to pull out and talk about. Okay. All right, our learning objectives for today are these. And so my classes each day are going to start with this type of learning objective aspect. That's an interesting noise. The learning objectives are designed for you to be able to organize your notes as you're going through class. So definitely anticipate that you're going to want to have a notebook that you take notes on during class. If it's a laptop or a tablet, that's fine. Don't mind at all. I will have handouts sometimes during class that will help you annotate things going through that particular lecture, but that's not a problem. The learning objectives then are also designed for you not only to be able to orient yourself as we're moving through the lecture, but to be study guides for you, so that when it comes time for the exam, you can go back and say, do I know what the global freshwater resources are? Yes, I do. Do I know why we have the dependency and all these different aspects of sustainability? That's awesome. For freshwater resources, haven't had that happen before. Okay, and then we're going to talk about these different dilemmas today in freshwater resources, particularly drought and groundwater overdraft, which is a consequence of drought. We use all of our surface freshwater resources, and of course, it goes into our underground aquifers. At the end of I would say not so much at the end of class today, but the overarching principle for today is what I mentioned on that first slide, is is this idea of community interactions and watershed dynamics, that we can look at all these different freshwater resources and these different possibilities and start to put them all together. And this will roll over into what we start to talk about next week when we talk about the opposite of drought, which is flood, when we have too much fresh water on the surface. And then when we talk about water pollution, where are all these different sources of things that are causing habitat degradation in fresh and saltwater ecosystems. Everybody's cool with learning objectives, right? Sometimes we get through all of them, sometimes we don't. I will amend the slides for you that are on Blackboard for each day to represent what's actually in that lecture. And you might see one, usually it's the one that's at the bottom of the slide that rolls over to being the first one the next lecture. Okay, all right, so let's do it. My review question for today is, you tell me, please, those 3 pillars of sustainability that we used our little Post-it notes to come up with at the kind of very end of class on a Tuesday. That's first and foremost. And then turn to your neighbor, see if you can list these 3 pillars of sustainability. And then within one of those pillars of sustainability, we identified that there were 3 aspects to environmental science that were pretty important. Okay? See if you can come up with those 6 things. 3 pillars of sustainability, and then the 3 aspects of environmental science.
Yeah. Repetition is the only way to learn stuff.
Okay. Who can give me one of the 3 pillars of sustainability? Yeah, Cassie. Economy. And if I don't know your name, please tell me. I'll take you. Yes. Elena. And society. Society. Yes, Andrew. And the environment. And again, we're going to look at freshwater resources to start off with from these 3 kind of aspects. Why is it important environmentally? Why is it important economically? Why is it important to society and kind of human civilization? These 3 kind of organizing groups are good for really diving into different aspects, I think, of environmental science problems, particularly when it comes to forming good solutions. Okay, what about these 3 pillars of environmental science?
Yes, Rebecca, chemical cycling.
Chemical cycling. Yeah. Biodiversity. There are so many hands. Yes, ma'am.
Morgan, solar energy.
Solar energy, that's right. Okay, those are them. We can relate back almost everything we're going to talk about in environmental science to one or more of these things, okay? In terms of fresh water, it's all about solar energy, evaporating water to provide precipitation that's going to rain down and give us freshwater resources, okay? In that fresh water, we have a ton of chemical cycling, the first one of which is H2O, the water molecule in the hydrolytic cycle itself. When we talk about biodiversity of freshwater resources, it's all about habitats, the different types of organisms that live there, and all different types of organisms that are sustained by freshwater, including us. Okay, so what is very clearly the environmental pillar of sustainability then really quickly becomes involved in economic and social success of humans, okay? But it goes back to that environmental pillar of having that provided or available to us for our use. So they're really interconnected. that's another thing that I think you'll get really quickly out of this class is these interconnections and the idea that we have to balance these to some extent if we're going to understand problems and if we're going to make solutions. Okay, anybody questions? All right, the other thing I would say is that if we make a list on the board, okay, that's something that should be in your notes. All right, that's something that you should write down. Definitely these three things, because they'll come up over and over again, and you'll have them at your fingertips very easily and readily. If we make other lists of things on the board, it's usually in response to a question, and that's not going to be on the slide. That's in the lecture notes, what our answer to that question is. Okay. All right, cool. All right, so our planet is a blue one, right? If we look at Earth from space, and these are some of the most famous pictures of Earth from space, where we see these two hemispheric examples of this, we see that there's land, there's green, but there's also a ton of blue. There's all that white stuff, which are the clouds, the water vapor, that's also covering Earth. And so if we want to talk about life on Earth and we want to talk about cycling and what's happening, we're super interested in water, okay? Water is the Earth's largest habitat, okay? It covers, 71% of the Earth's surface is just in the oceans. Okay? What happens there becomes very, very important for what happens on land. Okay? The oceans touch us constantly, even though we're in a plateau. All right? 50% of the oxygen that you breathe in every lungful comes from phytoplankton in the world's oceans. Okay? Every time it rains, most of that water and precipitation, the snow that we're getting today, originates in the world's oceans and in nearby freshwater resources in terms of that hydrologic cycle, water vapor being evaporated, and then it condenses into the precipitation. Okay? We tend to get a disconnect here in the middle of the United States from what's happening with our water resources, unless you live right next to a lake, unless you live right next to the river, if you're right next to a dam or an impound reservoir, okay, then you're pretty concerned about it. But by and large, all we tend to think about for our freshwater and water resources is what comes out of our tap and whether or not the sump pump is working, okay? But I want you to recognize that actually most of our world is water, okay? We're a smaller fraction of what's happening compared to what's going on in water resources. Okay, so when we think about water resources, the biggest one, and I'll give you the stats for this in just a second, is our saltwater environments and ecosystems. And we tend to divide the world's oceans into 4 main oceans. Can you guys name for me the 4 ocean basins? Yes.
Atlantic, Pacific.
Good.
I'm trying to think of the other ones.
Okay, we'll start with those. Okay, here's the Atlantic Ocean. That's this one that's between North America and Europe and Africa. The largest one is the Pacific Ocean. It's also the deepest. Of course, that's between the Americas and Asia and Australia. I'm very interested in what is happening with the projector today. We'll continue on like there's nothing strange happening. We don't have those. Anybody can name me one of the other 2 oceans? Yeah.
Arctic Ocean.
The Arctic Ocean, good. That's the one that's up here. Okay, it is actually an ocean basin. It's the youngest and the shallowest of the ocean basins. It's the one that is formed most recently in plate tectonic movements. And there's no land mass there at the North Pole. It's just water. It's different from what's happening in Antarctica. Okay, and the 4th one, the Indian Ocean, good. And that one is this ocean basin that's between Africa, Asia, and Australia, kind of bordered by Antarctica down here. Okay, those are the 4 ocean basins. The Atlantic, the Pacific, the Arctic, and the Indian Ocean. They all have slightly different characteristics, but they're all connected to each other. Water flows from one into the other on really long time scales and sometimes very quickly. The main place where these different ocean basins mix is down here in what's often called the Southern Ocean. We have a circumpolar current that flows all the way around Antarctica and takes water from places like the Indian Ocean and mixes it into the Pacific Ocean and then over into the Atlantic and back around into the Indian Ocean. There are other currents then which take the water that's cold here and drag it up towards the equator, and then we have other currents which take it from the equator up into the Arctic and then back around. Does anybody know how long it takes for a water molecule to go from a place in the Pacific Ocean all the way through the ocean currents back to that spot in the Pacific Ocean? It is a long time. but it's actually not like a super long time. It's longer than a year.
5 years.
It's longer than 5 years. More than that.
50 years.
Takes 4,000.
Oh, wow.
Okay. So again,
That
it's
is like longer than I thought it would be.
that's fine. It's long in terms of a human lifetime. Okay, like in your lifetime, that water molecule is gonna go like burp here. Okay, it's not gonna get very far in a human lifetime, even in a couple of human lifetimes. But in terms of the age of the Earth, which is like 4.5 billion years, okay, 4,000 years is tiny and actually pretty fast. All right. So when we think about the hydrologic cycle, the other thing I want you to recognize with these resources is that it's actually fast. Okay, we had that one word that we didn't put in a good category on Tuesday, that was rushing, that described water. And that's actually a good word to keep in mind, that there's a movement to water resources that we have to take into account. And that very often when humans interact with water resources, we're going to be changing that movement and normal cycling of water. And that can be a source of a lot of our problems, particularly when it comes to freshwater resources. And hopefully that also gives you this idea that we think about short time scales, what's happening day to day, what's happening week to week, what's going to happen in our lifetime, maybe what's going to happen with the next generation. But there's a longer time scale of the Earth's cycles. Okay, and we think about chemical cycling, and we think about these things, there's a long time scale to what's also happening behind our kind of scenes, and we have to balance those things. Okay, we have to be aware of the cycles on these different temporal and geographic scales. And again, often our problems come with fail to recognize that, or we fail to take that into account. Okay, so when we think about water resources then, we can say that 73.2% of the Earth's surface is covered by water. Okay? The vast majority of that is held in those big ocean basins and is salt water. So out of all of the water that's on Earth, 96.5% of it is salt water, has some salt content greater than 0. And that's what kind of moves us into the salty category. Again, there are various definitions for the salinity of water based upon how much salt is dissolved in it. But when we think about fresh water, it's got to be 0, okay, in terms of the salts that are present in it and measurable on our salinity scales. Okay, this means that just 3.5% of all of the water on Earth is fresh water. Most of that fresh water is frozen or underground. Okay? Of that 3.5% fresh water, half of it is frozen in glaciers and Antarctic ice sheets and in the Arctic. Okay? Half of that fresh water is underground in what we call aquifers, water that is trapped underground in different rock layers. Okay? Of the total water on Earth, that frozen and that underground aquifers is 1.7% of the total water that's on Earth. Okay, so of the fresh water, half of it is frozen, half of it is underground. That means that a tiny, tiny, tiny fraction of fresh water is readily available for our use as surface water, freshwater resources. Out of the total, it's only 0.024% of all the water on Earth is what we consider surface freshwater resources that you can go and scoop up full of. Okay? And that's really easily and readily available for you to flush your toilet with, or to cook with, or for us to irrigate crops with. That's a little bit of water, okay, in comparison to all of the water that is out there. That means that although this water is a lot, because the amount of water on Earth is very vast, we actually are dependent upon just a small, tiny fraction of water that we can readily access. It costs us more money, it takes more time to melt water from glaciers and ice caps to use. It takes more time and energy and money to get water up from out of the ground for us to access. It's much easier to just pipe it out of the lake into our manufacturing plants or into our homes, and that's what we generally want to do. That means that we have to be very careful with this tiny little amount of fresh water that we have to work with. And thus far, we've been fine to some extent. Okay, we haven't really run out of this fresh water. We're just getting to the point where we're starting to see different areas of the world that are needing to trade in freshwater resources, that don't have enough fresh water for their current human populations, and they're looking at other watersheds around them, whether in the same country or other ones, in order to get access to fresh water. We just reached a human population and use of freshwater resources that's kind of equal to the amount of fresh water that's readily available for us. Yeah,
Is water owned by whatever country it's in?
it is. Okay.
So you have to purchase it?
You do, or trade for it, or broker a deal with it. And what we're gonna see in, as we look in California in the Colorado watershed, is that the Colorado River starts up here in the United States, in the western United States, and it flows down all the way through Nevada, New Mexico, Arizona, and it goes out through Mexico into the Gulf of Mexico. Or it used to. It doesn't anymore, because the United States uses all of the fresh water coming out of the Colorado River. It no longer flows into the Gulf of Mexico. It actually stops somewhere in like the Arizona region and peters out into the desert today. We didn't talk to Mexico at all about the fact that we were gonna take all the water out of the Colorado River. Okay, but it definitely affects people. Okay, all right, so turn to your neighbor. You can talk to anybody that you would like to, maybe somebody different than who you talked to previously in class today. See if you can come up with 3 reasons why we, as humans, need fresh water. Okay? Maybe once you thought of some reasons why humans need it, you might think of some other uses of fresh water, which would be nice. But think about humans to start with. Why do we need fresh water?
To drink, to bathe, to grow food.
Yeah,
Yeah.
general life.
Yeah. But also, agriculture too, but that also would be a huge amount of.
Mm,
Laundry. Humans like to live their best, fish out water. Hydraulic energy, that's another reason we need energy.
yep.
Okay, why do we need
Transportation,
fresh
boats.
water? You have to come up with 3 we're gonna do. Yes, sir.
Energy.
Energy, and what's your name?
Caleb.
How do we, so first, before we move on, how do we get energy out of water? Hydraulically. Yes. Yeah, Caleb?
Well, one of the things that I saw was that, like, they use it to cool off stuff when they're using other sources.
You can turn a generator.
What else? How do we get energy directly out of water?
Dams.
Good, and what happens at dams?
That turns a thing that creates energy.
Yeah, it turns that thing and you get electricity
Turbine.
out of it, right? That's
Water
Yeah,
flow.
that's exactly what happens. We use water to turn the turbine, which runs a generator, which makes electricity. Okay, we'll do some more details of that when we talk about renewable energy resources. When we think about hydroelectric. Okay, we can actually get electricity out of running water, moving water. That's another thing here. Okay, why else do we need water?
To live, I mean, we have to drink.
Live, drink, yeah, food. Food, and what are you thinking of with food?
Agriculture. Or grow crops.
I think I heard the other one.
Grow crops.
Grow crops. Good. Okay, and I heard this one, need it to live. When we talk about living, what are we thinking of here?
Drink water. Drink the water.
You gotta drink it. Okay. You gotta have a certain amount of fresh water each day. Or you'll conk out after about 3 minutes. Yeah. Good, I'm gonna put that one under this. I'm gonna say sanitation. Okay. Did I spell it right? Don't answer. What else? Yeah, Dominic.
Goes under living, but cooking.
Good.
Great.
And what kinds of recreation can we do?
Swimming.
What else? What if we think about not just human uses of fresh water? Good. And what kinds of things live in water?
Fish.
But fish again. Okay.
Froggies.
Turtles,
Frogs.
dolphins,
Yes.
whales.
Sea cows.
Okay, anybody for sharks? Okay, they fall under fish.
I go with manatee.
So we've got seaweeds, we've got coral reefs, we have kelp forests, we have algae nets, all right, all that is that habitat. Okay, there's even little things, like crabs, crustaceans, shrimp, krill, daphnia, water fleas. Yeah.
Starfish. I feel like I'm remembering vaguely in my last class that we talked about oxidation.
Okay, what are you thinking of? Like,
Like we needed water for some sort of chemical cycle. I can't remember exactly.
water in its erosional capabilities, I would say. And we can put the hydrologic cycle itself. Are pretty important. A lot of our chemical cycling in one part or another is based upon the weathering of rocks. And water does that. Either wave action on the shorelines of different places, or precipitation events, or even things like freezing thawing processes can break apart rocks. The movement of water through that hydrologic cycle moves around these different chemicals, and in some portions you're making oxygen. Okay, it's a little tiny fraction compared to photosynthesis and what organisms are doing in terms of oxygen cycling, but it is there. Anybody else? Yeah. Does it like help with medicine? You could put it under, you want to go under living or energy in terms of manufacturing. And in this case, it's a vehicle for administering medications. Right, it's a delivery system. And I mean, so many of the things that we look at and we utilize today, if you look at it, water, is one of the ingredients to this. And so we don't get a ton of medicines like directly out of water. Lots of the organisms that live in water are potential biopharmaceutical resources. But the water itself is like a delivery service. I feel like we have,
I was in here last summer. It does that, and then there'll be a weird rattling sound that comes from
Out of
that
the
vent.
vent.
That you'll think it's somebody tapping their pen or their foot on the back and want to kill people, but it's just a vent.
okay, we're all gonna have to like develop a way.
Put a pillow over it.
Voice and not complex. Okay, so why do we need fresh water? You guys got it by and large. Got these big points where we see the importance of fresh water in particular resources. Definitely salt water is in this too, but we're really focused on fresh water. So fresh water is crucial to us because and we need it for drinking. And that's that life perspective. In humans, 60% of your body is water. And so you must have it in order to survive. The other thing we want to recognize is that for all types of life, usually at least 70%, and usually more than that, of the cellular kind of volume of a living cell is water. And so it's not just humans, of course, that rely upon water for their major resource, but it's all types of plants and animals and prokaryotes and bacteria and archaea as well. They have to have access to this. And there are different ways that they can utilize salt water to make it fresh water, but by and large, it's the fresh water that they have to extract and must use. Okay? Again, that kind of life perspective that we have, we must have water, particularly fresh water, in order to provide for our own food resources in addition to hydration drinking purposes. We need it to raise livestock, we need it to grow crops, okay, particularly in irrigation. Next, we have to have it for sanitation. For a long time, and even today, still, one of the mantras of the uses in freshwater and the removal of waste is that the solution to pollution is dilution. That if you put it into water resources, it will dilute out and become less toxic and less concentrated, and it will be washed away by the water. and thus we can provide for our sanitation. Okay, we do that when we bathe, we use water for washing, we do it when we flush the toilet, we use the water to rinse away our waste. If it goes into a large enough reservoir, this works, okay? But we're starting to see the buildup of these types of waste in terms of different types of water pollution as human population has increased explosively over just the last few decades. Okay, we'll get into those types of sanitation, sewage pollution problems next. Remember too that, well, I think it's on the next slide before I get into my statistics. Okay, we have that hydrologic cycle. That's important in terms of water, moving stuff around, providing for the distillation of fresh water out of saltwater resources. And then finally, fresh water is important as a habitat. We have all these different organisms that live in it, and many of these organisms can be found nowhere else than in the particular habitat in which they live. I'm proposing my email to IT. You've got to check out. All right. So those are the biggies of why freshwater is important. I have some more things to tell you a little bit out of these perspectives of the 3 pillars of sustainability on the next slide. You gotta have it to drink, you gotta have it for food production, you have to have it for sanitation, we must have it for the hydrologic cycle, and it has to be healthy. Does anybody recognize the dam that is in the picture? That is the Hoover Dam, the largest concrete structure in the United States. Pretty impressive. It is on the Colorado River, and it creates, what is it, Lake Mead behind it? This big freshwater reservoir. It was built kind of in the 1920s, 1930s era as one of these Great Depression, movement into work projects by the Army Corps of Engineers, and it is part of the foundation of the population wave that went into the Western United States. Without these types of construction projects, not only would the economy not have been rejuvenated in these areas, but they wouldn't have access to these big freshwater resources that are necessary for drinking, sanitation, and irrigation for those Western populations. Okay. Freshwater is absolutely crucial then to the health and economic sustainability, particularly of humans. Not only do we need it for drinking and water production, but we need clean water, okay? The water has to be free of pollutants and toxins, and it needs to be free of pathogens, of disease-causing organisms. And this is something that I don't think we appreciate to a great extent here in the United States. We take for granted that the water that we have access to for drinking out of the tap or bottled water resources is clean. But 780 million people around the world still lack access to day-to-day clean drinking water, okay, whether it's pollution or disease-causing organisms. That's a big fraction of the Earth's population. And we think about it here in the United States, that something like 93,000 people in the United States lack access to clean drinking water. That has real impacts for health of these types of populations. 9,300 people die every day from waterborne illnesses. The biggest epidemic of this today is in Yemen, where they have a complete breakdown of societal services. And so most people in Yemen no longer have access to clean drinking water, and as a result, they have a huge cholera epidemic and outbreak happening. We see that in terms of our own health and economy, we're relying upon water for the production of seafood. Again, we're taking somewhere on the order of 110 million tons of seafood out of the world's oceans. That provides somewhere on the order of 7 to 10% of world protein resources just from water. Again, the oceans produce about half of the oxygen that we utilize for breathing as cellularly respiring aerobic organisms. So we can't do without these water resources. And there's millions of jobs that water provides for. Most predominantly, we tend to think of this in terms of fishing resources. There's a ton of jobs in sanitation services. There's a ton of jobs in hydroelectric. There's a ton of jobs in the support industries for those traditionally water-related jobs. So it's not just the environment, it's not just our day-to-day bodily well-being, but also our overall health and economy as a society is really dependent upon water resources, both salt and fresh water. We have one more slide on the importance of fresh water, and then we'll talk a little bit about drought. If I go too fast, let me know. If you're like, oh, I need to go back to the slides, don't hesitate to let me know. Keep in mind, the slides will be on Blackboard. Usually, I upload them right after class before I leave for the day. If you miss something, you need to put a little asterisk in your notes. I was working on the slide, but I didn't get a chance. Okay, the last thing we have to remember about that fresh water is that it's important for social reasons. And again, recreation tops this list. There's all kinds of recreational opportunities around fresh water. This is something that got me interested in environmental science because I love to be on the water. I love to be in the water. I love to fish and swim. I love to go boating. I love to see the organisms that are in the water. And when I noticed the problems in the freshwater resources around me, then I got really interested in environmental science, what was causing them, and how could we start to address them. Again, I mentioned this earlier, we're starting to see in our social realm of freshwater resources a conflict for access to fresh water. And that as our population has increased and we have an increasing usage of water in lots of different areas, there's not enough fresh water. And this is, of course, more problematic in desert, drought-prone regions than it is in regions like ours or right next to the Great Lakes. This is huge freshwater resource. But we start to have to think more closely about how we're going to manage our freshwater resources because our underground aquifer in our region is being overdrawn, despite the fact that we still continue to have seasonal floods. In the environmental area, just remember that there's a vast biodiversity in our water resources around us. There are several phylos of organisms that are not found on land. They're totally water dependent. And so what happens in the water has a big impact on biodiversity. Again, one of those big pillars of environmental science. And the misuse and the pollution of freshwater resources then directly affects this biodiversity. It can endanger and cause the extinction of organisms, it can wipe them out in portions of their geographic range. And every single time we have pollution of a freshwater resource, we're engaging in habitat degradation and disruption for one organism or another, including ourselves. So we've got to have it. Okay, everybody's crystal clear. Everybody, water's H2O. All right, okay, so we're going to look at these kind of 4 aspects of human interactions with aquatic ecosystems over the next 4 or 5 lectures. We're going to start today with water scarcity and drought when we don't have enough. We'll then talk about flood. We'll spend a couple days or more talking about pollution, and that'll lead us into this idea of direct habitat destruction of wetlands, ecosystems, and water resources. As we talk about urbanization and stormwater runoff, which link into other things like flood and pollution as well. Okay. This particular picture is of a floating trash pile. That's behind the Three Gorges Dam in China. It can be pretty profound today, the types of waste that we find in our freshwater resources. And this picture, I think, gives you a little flavor of that, which again we'll dive into detail starting next Thursday. You see that there's floating wood debris here and organic matter that's part of the water pollution. We see that the water is discolored, it's full of sediment or dirt. We also see, of course, that there's floating plastics and other types of trash. And this degrades the habitat not only for the organisms there, but the people who are obviously there. What's interesting here is that the people that are probably in this picture are actually mining this floating trash pile for recyclable or useful objects that they can pull out of the trash and turn into money. Which is an interesting thing.
A marine dumpster dive.
Yeah, a marine dumpster dive. But I also want you to maybe start to think about, like, we're like, oh my God, that's gross and disgusting. Like, I would never do that, okay? But think about what kind of position a person would be in that they would be like, oh yeah, today I'm going out and I'm going to pull trash out of the trash heap behind the dam. Okay, like, where do you need to be in life? What is your life situation like where that's your job? You know, that's the thing that's gonna earn you the most money. That's the thing that's gonna let you sustain your family. Yeah, when you're living in a place that looks like this. And I think that one of the things that environmental science does for us is it lets us identify those places where we're not meeting quality of life standards, okay? And where, if we look at it as an environmental science problem, we can see how to improve quality of life for people. And I think that that's one of the, that's like the take-home message of environmental science, that once you get a healthy environment, you will get a healthy society and healthy people as well. And until you solve those environmental science problems, this is going to seem like a good way to live your life. Okay, all right, so let's start with water scarcity, and that's drought. All right, here in the Ohio River Valley, we have lots of sources of precipitation. We have seasonal floods. We don't tend to have drought conditions. We might go a couple weeks in summer, kind of like late July, early August, where we don't get rain for a couple weeks and the grass starts to brown out and the leaves start to fall off maybe a little bit early. But we are not generally in what we in meteorological terms. And so in meteorology, in terms of the hydrologic cycle, we have very specific definitions for drought. And drought then is an extended period when you have a lack of precipitation that results in negative consequences for the environment, for society, and for the economy. Okay? If you have a lack of precipitation for a long enough period of time that you start to get negative environmental and social consequences, then you're in drought conditions. And so depending upon what's normal for your region or area, it can take you longer or less time, or a lack of water for, in a more severe sense than others before you push yourself into drought conditions. By and large, drought is caused by a lack of normal precipitation. You have below average precipitation. And again, that can be snow or rain, depends upon your. So you can have drought in places like Antarctica, where it kind of never rains, but they have snowfall. You have less than average snowfall in Antarctica, you can enter a drought region. And there are desert places in Antarctica where this is part of their ecosystem. There are short-term and long-term droughts that we identify, most particularly for use here in the United States in our kind of drought monitoring systems. Short-term droughts tend to be less than 6 months in length, where you have below average precipitation that has some negative impacts for less than 6 months. In general, short-term droughts will impact agriculture and grassland ecosystems in terms of those habitat social consequences. You'll have drought for one kind of growing season that affects crop productivity in that growing season. But the next year, you're okay. Short-term drought is not going to cause impacts on freshwater ecosystems. Those will be able to replenish themselves. Short-term drought usually doesn't impact our underground aquifer resources because it's going to be replenished pretty quickly. You might start to draw from them, but it's still within the kind of norm of the hydrologic cycle. Okay. Long-term severe drought that lasts for over 6 months is much more ecosystem and socially economically devastating. In those types of instances, we're going to impact the actual hydrologic cycle itself and the overall ecology of a region. We're going to go from a grassland to a desert ecosystem permanently as a result sometimes of long-term severe drought conditions. Okay, you're not just going to get a dieback of the grass that can regrow the next time it rains. You're going to wipe out the grass in its root system and it will not regrow even if it does rain in that particular region. That long-term severe drought is the thing that we get really concerned about as humans because it impacts how much freshwater resource we have access to, both above and below ground. It fundamentally changes how much fresh water is available for us for all those various reasons. Okay, has anybody lived in a drought? Yeah. Where were you?
One was here, like 20 years ago.
Yeah, what happened?
And, basically everybody's lawn died, and you were restricted on the hours like that you could run water, and there were advisories about even showering and laundry.
Yeah. That's generally what happens in societies where we have long-term drought is that you start to see restrictions on freshwater resource use because there's not enough for everybody to utilize in the normal day-to-day course of life. The thing that usually comes up first is that you can't water your lawn, so the lawn dies, and you can't wash your car, okay? And so everybody's car gets a little wrenchy. When it gets severe enough, you might have daily water outlets, and so that your tap will only run for certain periods of the day, and then at another time period, your tap water turns off and it switches on for somebody else, and you got to do all of your washing, all of your cooking, you got to do all of your showering and laundry in that time period when you have access to fresh water. And you might even be regulated on your gallon use per day. That's severe drought. Okay, that's what's happening in South Africa, kind of in the last couple of years. All right, we've had record-breaking drought in the western United States from 2012 through 2016. This particular infographic shows you through 2015, and it was most severe in the California region. And you can see kind of the spread of the severity of the drought here from one year into the next. And this is long-term drought, where year after year after year, they had below average precipitation. And as a result, then, they got the spread of these drought conditions. The darker orange color is more severe drought. You'll notice that by April 13th, 2015, most of the state was in an exceptional drought condition. They're in these types of water restriction scenarios. Right? It was phenomenal, the lack of precipitation that California and neighboring kind of Nevada, Arizona, New Mexico were experiencing. It even touched a little bit into southern Oregon, and then once you got kind of over the Rocky Mountains, it was okay. It was a similar time period, though, kind of the early 2000s, that we had really severe droughts in Panhandle, Texas, and Oklahoma as well that impacted livestock ranching in those areas. Okay, at the worst of the drought, the height of the drought at the kind of summertime 2015, we can see the extent of the drought in California in these regions. This is the U.S. Drought Monitor. It can show you both on a kind of national scale as well as a county by county scale what the drought conditions are for any place in the United States. It comes out like once a week, usually on like Sunday nights, if you get interested in these types of meteorological conditions. And you can get these interesting maps like this that show you the extent of drought and how it can shift kind of from week to week as you do get precipitation in different areas. But at the extent of the drought here in California, they had, let's see, about 38 million people that were in one form of drought or another, and 41% of the state was in the most severe water deficit category, that exceptional drought. What this resulted in, first and foremost, was the extreme drawdown of the freshwater reservoirs that had been set up within the state of California in order to provide fresh water to these communities that didn't have access to surface water resources to begin with. These are places where we had running water that we put a dam in order to create a lake behind it then that we could draw water from. These are the two most highly impacted reservoirs by this drought in California. This is Lake Oroville, I believe it's pronounced that way, in 2011, and what it looked like 3 years later, 2.5 years later, in 2014. This is Folsom Lake, again in 2011, and then in January of 2014. That's what drought looks like. Okay. I kind of like these pictures because you can see the water depth change and how it's impacting ecosystems. And you can see how it's starting to impact people in these regions too. Okay. These are freshwater access points, particularly in Folsom Lake, where people can get out on the water and go boating, and then like your boat is literally high and dry. Okay. You can't get into these water resources to use them in a safe way. That should also kind of signal to you the amount of water that's being used by people and ecosystems in this region. Okay, there's millions of gallons of water in each of these reservoirs, and it's gone over the course of this drought. And this is 2014 levels, even before we got into 2015, 2016. Like, the drought continued on after this. Okay, so what did it look like at the height of the drought in California? All of their reservoirs were below their historical average level. This is what it was showing. Again, I think in 2014, at the end of 2014. I looked this morning to see where these reservoirs were today in 2019 now, January, and they have all recovered because we've had rain That's been above average in most places. In 2018, 2017 is when California was able to break out of their drought. They got into a La Nina cycle, which is where they get more heavy precipitation, and that allowed these reservoirs to be recharged. The two most severely impacted, like Oroville and Folsom Lake, they remain at about 30% capacity though. They have not fully and completely recharged. And so again, that gives you this idea of not only how much fresh water was missing out of this ecosystem, but then how long it takes to replenish. It's not something that happens overnight with one precipitation event. It can take a long, long time to do that. Because remember that it's not just the water that has to pool on the above ground, it's going to be trickling down into the subsurface arena as well. You've got to fill up all those deeper reservoirs before we can fill up the surface. Okay, so what did this mean? It meant a lot of stuff for the people in California that experienced the drought during the period. First and foremost, we had people that were impacted in terms of recreation. Boating and fishing was very limited simply because there was less fresh water in which to do those types of activities. Part of the cause of the drought in California was a lack of wintertime precipitation in the Sierra Nevadas. And so we saw that lots of the ski resorts in California had really, really severely restricted seasons, and there wasn't a lot of snow there to do stuff on because it wasn't snowing. And that has a recreational consequence, but also has a big economic consequence. These are communities that expect a seasonal influx of visitors, either for summertime or wintertime recreational opportunities, and the people aren't going to come. They're not going to buy gas. They're not going to eat at the local mom and pop diner. They're not going to stay in at the hotel. Okay? They're not going to be buying ski passes when you can't go. And so that starts to have economic consequences in a non-agricultural context for these types of drought conditions. The other big impact of California drought was on agriculture. And this is a reminder and the recognition that a lot of the United States agriculture actually comes from California, not in things like wheat and rice and soybeans, but in things like our vegetables and our fruits. A ton of things like our lettuce. 74% of all lettuce in the United States is grown in California. 90% of all tomatoes, 92% of strawberries and grapes and broccoli, 99% of all almonds are grown in California in these drought-hit regions. You may have noticed that the price of these items went up recently at the grocery store, particularly during times of the drought, big time almonds in particular. And you're like, why does it cost $10 to buy a bag of almonds? All right, because there's drought in California. That impacts not only the farmers, okay? They can't grow anything to make themselves money. It impacts us then when we go to the grocery store, even though we don't live in California. Okay, all right. So in January, at the start of this year, this is the most recent drought monitor for the continental United States. We can see really easily that the drought has broken in California in terms of those severe drought conditions, although we see that they are still below average precipitation in many parts of California, and that has contributed to the really severe fire seasons that we've seen in 2018 and 2017 in this region. The ecosystem remains dry. There's freshwater resource in order to do things and sustain the economy again, but it's not there in terms of ecosystem resources. So it's still really, really dry, and that has promoted these big wildfires that we've had. What portion of the United States today is under these extreme drought conditions? Yeah, which region? Do you know what we call that?
Around, yeah.
It has a, we call that,
Sierra.
does anybody know?
No.
It's the Four Corners region, right? Because you can
Four
stand in one place and be in like 4 states at once, right? It's the Four Corners region, all right? That little bit of, what is this? Utah, Arizona, New Mexico, that's Wyoming, this is Colorado. Is having really severe exceptional drought today. Okay, there's not a lot of people that live out there. Okay, so it's not making the news like it did when we had drought in California. But recognize that this is common now today in the United States. That one place or another is going to be experiencing severe drought, even in the middle of winter. That starts to have these economic, social consequences beyond just environmental consequences. Okay. So what was at risk during this drought? This is a nice little infographic that the California Farm Water Coalition put out just to kind of remind you of these different impacts of drought conditions, even here in the United States. So we lost $2.8 billion worth of agricultural income. That was 6% of California's total activity, $11 billion in state revenue. 40% of the Central Valley jobs were affected by this type of drought. When we look at, what's at risk, 95% of California's agriculture, 1.4 million jobs. Okay, like that's a big deal in the largest economy in the United States, which California in and of itself is in like the top 20 economies across the globe. Okay, so when something bad happens in California, it has a ripple effect to what's happening across not only the United States, but also the world. Okay? In total, the state needed to get about 11 trillion gallons of water to replenish what had been lost during the drought. And that's, again, they have come a long way to move out of this drought, as we've seen, but it has taken years to do that. Just as it takes years to dip down into freshwater resources, it takes years to rebuild from that. California did a great job in managing their drought once they realized they were in it, and that they were in it for the long haul, and they took on all these types of water restriction things. They did all kinds of things to help people limit their water consumption and to give them good guidelines, and they started fining people, actually having a big penalty when they saw people watering their lawns or washing their car or taking too much water on their meters beyond what they were supposed to use. But we still had problems in the Central Valley in California where we had communities where the wells went dry and the state didn't do very much of anything in order to provide them with fresh water, even though they were in the middle of a natural disaster. Okay. We have a misconception sometimes about what constitutes a natural disaster and what the need of federal assistance and federal aid. A drought, you're like, okay, it's a drought, big deal. Your home is still standing, but you can't live in it if you can't take a shower and you can't flush your toilet. How are you going to go to your job each day when you're sticky and smelly, and so are all of your coworkers? Okay. How are you going to manage your job and go into school and stuff when you got to travel 30 or 40 miles each day in order to buy fresh water? Okay, that's something that you probably didn't budget for. And again, that's something that I don't think that we tend to think about until you find yourself faced with a drought condition of how important and how much you take for granted our freshwater resources until they're gone. Okay. The outcome of this in California, of course, was severe fire seasons that we saw in California, both in the years of the drought and even continuing after that. This is, of course, the ridgeline of the Camp Fire that occurred this past fall in Southern California. I think what's interesting now is that even though the fire season has broken for this kind of time frame, this is the time when California is getting precipitation, when things are recharging, when it's harder for weather conditions to actually start fires in California. Because the government is shut down, we're not managing our non-fire season in California as we should be. We're not doing all the fire prevention measures on federal lands that we should be doing in California because of the government shutdown. We're not giving grants to fire devastated communities right now because the federal government, that portion of the federal government is shut down. And so there's all these factors that come into play when we think about managing these natural resources. And again, when everything's going fine, we don't tend to think about it. When the system breaks down, though, it can be catastrophic for these communities. Okay, all right, so what caused this problem in California? All right, the drought in California, it definitely has its roots in a combination of things. One is weather conditions, where they had this lack of precipitation, and the other is people. And those two things exacerbated each other to provide for the severe drought that happened in California in 2012 through 2016. All right, yeah, okay.
One of the things that I heard was that if there wouldn't have been people in California, if the forest fires would have been, because forest fires happen naturally
Yes.
all over the place. They
Very
said
good. That's right.
had they happened naturally and had they not been stopped, the drought may have ended earlier.
Yeah. I mean, there's something to wildfire where it removes vegetation that's going to be drawing up water from the ecosystem. And so prevention of fire and keeping wildfires out of urbanized areas keeps that vegetation growing. So where it's going to have more water uptake and more evapotranspiration that exacerbates drought conditions. It's hard to say in particular regions what was the main cause of any given fire, but definitely those types of things add to the problem. The other thing to consider in California is that they're more catastrophic today because we have more people living in California in wildfire-prone areas. As the population of California has exploded, more and more people move out into these wildlands that burn naturally on the seasonal cycle. And when that happens then, as it should naturally, then somebody's gonna get hurt and impacted by it. It's totally unfortunate. It's a good example of where we have to think about how we're managing the system to where humans, first and foremost, their safety is there, which we have not done so far. And then is there an environmental scenario here that can help us with that human safety and welfare? And we have been totally oblivious to it. Okay, super quickly, what's been happening in California in terms of weather during this drought is two things. They had really high temperatures, okay, so lots of water was evaporating, and they had a lack of precipitation. So they got this like double whammy of conditions that caused the initial drought in California during this time frame. We can see that their precipitation at this time was much, much lower than the average mean. We can see that the temperatures here were much, much higher than the long-term mean in California. So because it's dry and hot, you're going to get more evaporation. You're going to need more fresh water in the ecosystem, and it wasn't there. It wasn't coming. And so you've got those drought conditions, that lack of precipitation for an extended period of time. The other thing that happened to exacerbate the drought in California, I mentioned earlier, was that they had a lack of wintertime precipitation in the Sierra Nevadas. They didn't get snowfall that would then, when it melted, provide an input of fresh water in springtime to these ecosystems. And that meant that year-round, they were not getting the precipitation they would expect. There was no break every 6 months in what's happening in the hydrologic cycle here, and that gave them that extended severe drought. Here we're looking at satellite images of kind of the Sacramento and San Joaquin Valley and the mountain chains just beyond them, the Sierra Nevadas. This is in 2013 when they had normal wintertime snowfall in January. This was in 2014, the amount of snow they had. Okay. And so there's not going to be fresh water in that ecosystem come springtime when all that snow comes. Not only are the recreation and the economics then disrupted of these regions, but the overall ecosystem is. And it happens year after year after year.
Did they ever state what like a cause of the lack of precipitation and higher temperature was? Was it just global warming in general?
Yeah. It's hard to pinpoint exactly what happens because there are, you can go back, let's see, can I go back? There are cycles in terms of precipitation. You are going to get these patterns that happen. Some of it's linked to El Nino, La Nina cycles. Definitely these were El Nino years, which tends to dry out in Southern California. But it's exacerbated by climate change, by shifting evaporation and precipitation patterns that are going to affect this region in this exact way where they get less over time. And it's going to be cool. Okay. All right. The other problem here was people. And this is both an old problem in California in terms of water use, and it is a new problem in California because of their burgeoning population and because of modern day kind of uses and reliance upon fresh water in different ways than we have in the past. The old problem in California when it comes to freshwater usage has to do with the Colorado River Basin, which is shown here in this kind of upper image. And again, we see the Hoover Dam, which makes Lake Mead, which is one of these big dams. I'm probably pointing to it in the exact wrong place on the Colorado River Basin. It's one of these big dams, one of many on the Colorado River, that is designed to impound fresh water in one location so that it can be pumped to the communities that need it in California. Okay, so people in California, okay, notice no big rivers. All right, they're part of the Colorado River watershed. They're dependent upon the freshwater resources and surface water that's provided by the Colorado River in order to fill those reservoirs. Okay, they have all these big aqueducts that bring water out of the mountains into the big cities. In 1922, a long time ago, the 7 states that are around the Colorado River Basin divided up the fresh water that was in the Colorado River between them and their populations. They said, hey, Colorado's getting this much, and California's getting this much, Arizona and Nevada, you're getting this much. Okay? They didn't talk to Mexico at all, as I mentioned, which also has the flow of the Colorado River. And they divvied up the fresh water so they would essentially use all of it. Okay? And that they would be able then to provide for their populations, and they've shifted dynamics of water usage over the years to again provide for places like California and Las Vegas that have grown drastically in population and irrigation needs over time. Today, 70% of the river flow was diverted, and as a result, the Colorado River no longer flows into the Sea of Cortez as of 1998. It ends in the middle of the desert. And I have a nice video for you on Blackboard where you can follow this gentleman as he goes down the Colorado River and he ends up in the middle of this floodplain that used to be a virgin wetland and is now just dry, cracked earth where the Colorado River no longer flows. The problem with this water allocation system in 1922 was that they did a shitty ass job. Okay? First and foremost, they didn't allow for the water to be there forever and ever and ever. They didn't allow for the fact that maybe we shouldn't use all of it, that conditions might change. And the year when they allocated the water, there was a lot more water in the Colorado River Basin than there normally is. Okay? So they said, hey, California, you can have so many millions of gallons of water out of the Colorado River, but there's not always that many millions of gallons of water in the Colorado River, all right? So immediately they started to overdraw from this watershed, and they have been doing it now for close on 100 years. Okay, that's going to exacerbate any conditions that you have when you lack precipitation. Okay, you're already taking too much out of the watershed. When you get in that condition where you're having less precipitation than normal, you have no buffer for those drought conditions. And as a result, those reservoirs start to go down. Yeah.
Why haven't they tried to like change the amount of water so we get like?
Great question. Why have we not changed water allocation in the Colorado River?
People don't want to give up theirs.
People don't want to give up theirs. What else? They all have to agree.
Mhm.
What else?
We're delusional.
We're delusional in denial. That's hard today, okay? I might have said that was true in 1985, 1990. We keep putting off this problem, but now when we look at what's happening in the Colorado watershed, you can't deny the impacts of this. What else?
Money.
Money. Okay? It's to Colorado's advantage to sell a bunch of their water to California. They're going to sell as much as they have. Colorado has enough. You care fuck less about Arizona. Okay? They don't care what happens downstream. Okay? If you've got enough, why not use it? Okay? Up to this point, there's been no consequence. Okay? For overuse. So they use it. Okay. The other problem is a new people problem in this watershed. And that is the fact that today's average human in kind of ecosystem uses much more water, freshwater resources, than they have in the past. An average resident today in the United States uses 69 gallons of water a day for our sanitation and cooking and drinking purposes. A person in San Diego, on average before the drought, was using 108 gallons of water a day. That's a lot. That's a lot more than people in 1922 and 1945, 1975 were probably using in the Colorado River. And so not only did we have this misallocation of water, we thought we had more than we actually did, we were sending it out to places that needed it, but then we started to use more. We needed to use the extra that was ever left in the ecosystem. And again, that means that when drought hits, it's going to immediately have consequences. There's not a buffer for what can happen in the ecosystem. My activity for you today is to think about how we here in the United States use our freshwater resources. Okay? You and 3 other people, if there's 4 people in your group, that's fine. I have 2 graphs for you to label about how you think we utilize freshwater here in the United States. One of them is about kind of overall uses, irrigation, manufacturing, hydroelectric. The other one is about that daily use, what we do individually as a person. Okay, find your